Good morning. The last time wrote this equation C is equal to I omega omega P. Can you describe this in terms of this wheel? So you're seeing this wheel here. So what each of these terms are? Okay, now please try to define what is on the right hand side I. So what is I for this wheel? What is I for this wheel? What is I? I is actually moment of inertia. Moment of inertia is actually given by the equation I is equal to m k square, where m is the imaginary radius, m is the mass of the wheel and k is the radius of gyration, which is the imaginary radius at which all the mass can be placed and you get the same moment of inertia. Okay, so you can imagine. Now what do you think is the weight of this wheel? Now what do you think is the weight of the wheel? Okay, I'm holding it. 5 kgs or 4 kgs? Yeah, so 4 kgs can be m. And what is the radius of gyration for this wheel? So radius of gyration for this wheel, okay, in terms of meters. So how many centimeters is it? 30 plus 20, maybe 50 centimeters. So radius is 0.5. So here you can say the mass is equal to around 5 kgs and radius of gyration is equal to how much? 0.5 meters whole square. So you get this moment of inertia. Then what is actually omega for this wheel? What is actually omega for this wheel? So what is omega? So what is omega? Right now what is omega for this wheel? Right now what is the omega for this wheel? 0. Now if I rotate like 1 round in 1 second, so how much is omega? So that is omega is 1 RPS. So this is omega is 1 RPS. So 1 RPS is actually equal to 2 pi. Since it is 1, so this becomes 1 divided by, so since it is actually 60, since it is RPS, you don't have to divide by 60. Suppose if it is RPM, then you have to divide by 60. So you get in terms of radians per second, so it is 3.14 into 2, which is 6.28 radians per second, because this is RPS. Okay, this is for 1 second, it is not for 60 seconds, this is for 1 second. Okay, this is for 1 second. So you get this. So you know I, which can be calculated like this, you know omega. And omega, I said it is for 1 RPS. Suppose if it is for 4 RPS, then 4 rounds per second, then this becomes 4 and this becomes 4 multiplied by so much. So you get this omega. Okay, then what is omega p for this wheel now? Right now, what is the omega p for this wheel? So what is omega p? Omega p stands for what? Omega p stands for angular of precision. Angular velocity of the precision. It is not angle of precision, it is angular velocity of precision. That means how fast this angle changes. Okay, right now omega p is 0. If I try to rotate this wheel like this, 1 round about its axis in 1 second, then omega p can be 1 RPS, 1 round per second, which becomes 2 pi. But usually for most of the vehicles or any machinery, the axis doesn't change so fast. It might take like 0.25 seconds for, it might take like 4 seconds for 1 revolution or something. Okay, so it can be like 0.25 RPS or something. So let us say that now when I hold this, there is no couple acting on me. I'm holding it, I'm free. But when I rotate also, there's no couple acting on this. But when I try to rotate like this, the couple acts in a perpendicular plane. Okay, I want to know what is the value of the couple. The value of the couple is proportional to what? The value of I. That means more the mass, more the radius of gyration, it is proportional. Then it is proportional to how fast I spin. It is also proportional to how fast I change the angle. Suppose if I change the angle slowly, my hand is not feeling any couple. But if I try to change its angle fast, I'm feeling a huge couple like this. Okay, huge couple like this. Now when I'm trying to turn, when the wheel is trying to turn right there like this, when I try to turn, see it's literally trying to flip my vehicle outwards in the same direction of the centrifugal couple. Okay, so that couple is proportional to I, which is based on the mass of the rotating parts and the radius of gyration of the rotating parts squared, and then angular velocity at which the parts are spinning at, and also the angular velocity at which this has precision. So precision is basically change of axis, the rate at which the axis changes. Now we need to actually take it to the next level, where we actually find out the couple created on vehicles due to the couple created on vehicles due to the rotating masses of the wheel and also the engine. So let us now, so suppose if omega p happens to be like 0.25 RPS, sorry, basically if it is an RPS, so omega p, suppose if I say that the angular velocity is like 0.25 RPS, so how do you give it in radians? So how much is omega p then? So how do you calculate? It is 2 pi into 0.25 rounds per second. So it is per 1 second, and you get this value. Okay. Now can you calculate the value of C? Can you calculate the value of C, guys? First, the mass of the wheel was given. The mass of the wheel, mass of this wheel was given as 5 kg. Radius of this was given as like 0.5 meters. So 0.5 meters, radius of gyration was given as 0.5 meters, and this was made to rotate. This was made to rotate at an angular velocity of 4 RPS, but the angle of precision is like, it takes 4 seconds to go on round. It takes 4 seconds to go on round. So that means it is actually like 0.25 rounds per second. So that is only a quarter round per second. Okay, so can you calculate this fast? Your fingers should be fast, and then can somebody give the value of this? 5 kg into 0.5, I mean this. 1.57 WP. So WP is 1.57 radians per second. No, how much is WP? This is actually straight away 2 pi into 0.25 divided by 1 second. Huh? This is 1.575 radians per second. And what is the value of this? Omega? Huh? 25.12 radians per second. And then, so now what is the value of Y? 1.25 kg meter square. So what I have is 1.25 kg meter square multiplied by 25.12 radians per second multiplied by 1.57 radians per second. So you get this answer here as, so you have these units as now kg meter square per second square, which can be written as, this can be written as kg meter per second square multiplied by meters. This becomes newtons. This becomes newtons, and finally you get the answer in Newton meter. Please multiply this and get a value. Huh? 49.29. So this is 49.29 Newton meter. So this is 49.29 meter, which is like almost like applying a 5 kg. So 49 newtons is around, you can take it as 50. It's around 5 kg. So 5 kg of load at a length of 1 meter. The couple that you feel, no? The couple that you feel when 5 kg is applied like this, 5 kg is applied like this on a rod, and you try to hold it and balance it. Okay, you feel this resistance in the couple. The same couple is being felt by this. Okay, a 5 kg applied at the two ends, okay, in the opposite directions. The couple that you feel is felt when this rotates like this. But have I done that? So do I feel this? You can definitely feel this because you are trying to. And also I am not actually worried about here. Okay, in this problem I would not ask the direction, but you always know that the direction can be considered. Of course, you need to understand the vector diagram for that. Okay, I'll teach you vector diagram that's in the upcoming this one. Is it actually still recording? Okay. Now I can also show you the vector diagram for this. So I can also show the vector diagram. Guys, which rule has to be used for finding out the angular momentum vector? Right hand thumb rule or left hand thumb rule? Right hand thumb rule. The wheel was rotating like this. The wheel was rotating like this. So wheel was rotating like this. So let me actually consider a plane something like this. Okay, the wheel was rotating like this. So therefore, when the wheel was rotating like this, the angular momentum vector was like this initially. Okay, when I try to take a left turn, that wheel, instead of rotating like this, it started rotating at an angle like this. So instead of like this, it became like this. So the new angular momentum, this new direction is this. Now to change the direction, I actually apply what is called as the active gyrocouple. That is the couple acted upon by my hand. Okay, I am trying to change the direction of the wheel. So that is active gyrocouple. But this reactive gyrocouple is the opposite side. So let me show it with this blue color. Can you see this blue color one? This arrow shows the reactive gyrocouple. Reactive gyrocouple, and this reactive gyrocouple will give you the direction to which side the wheel will actually try to flip. Okay, so now to know the direction, you need to hold your hand in this direction. That is, okay, now you need to point this thumb in this direction, like this, in this direction, and your four fingers show the direction of the flip. Understand? So when you are actually trying to change something like this, so the reactive gyrocouple will act something like this. So you understand, when you have something like this, it will flip like this. So that is what happened here. So I'm trying to rotate it forward here like this. Okay, forward here like this. When I try to turn like this, it is trying to flip like this. Now when I try to turn to the left side, it is trying to flip it to right side. Now the same thing can happen ulta now. Now I am trying to rotate it ulta. Okay. Now if I try to rotate it to right side, see this? I am trying to steer the wheel to the right side. It is now steering to the right side itself. Earlier it was steering to the left side. Have you got the concept? So now for this, now for the previous one where the wheel rotated forward, I actually considered where the wheel rotated forward, I considered this momentum. Suppose if I have to draw a momentum diagram for this, where I have to draw the momentum diagram for this, where the wheel is rotating backwards, like this, how do I do it? The wheel is rotating backwards means how I should hold this, how I should hold my fingers, like this. Now this is pointing towards this. So how I should draw this? So this is the plane. So this is the direction. It is the direction. The wheel is rotating like this, these four fingers, and this thumb is pointing like this. I want to turn like this. I want to turn like this. So four fingers which were like this becomes like this. Okay, the four fingers which are like this becomes like this. So that means it is turning like this. Now to turn from here to here, this is called as the active gyrocouple. To turn in the, now what happens? Because of the active gyrocouple, there's a reactive gyrocouple, and that reactive gyrocouple is given by this. Okay. Now, what does this reactive gyrocouple do? What does this reactive gyrocouple do? If you want to know, then you should hold your thumb and these four fingers in this direction. In this direction, will show that it is trying to flip it to the right side. When you want to take a turn to the right side, it will flip it to the right side. Okay, so this is how you try to draw the vector diagrams to know to which direction the gyrocouple is acting. But luckily, in all our vehicles, are the wheels rotating forward or backward? The wheels are rotating forward, so it will always try to flip along the direction of the centrifugal couple. The centrifugal couple always acts outwards, no? So outwards from the center of rotation. Okay, so it will act towards outside. Okay, I think the engines may be rotating backwards, but I have not seen any engine which is rotating backwards. The engines also rotate in the same direction of the wheels. So both the engines rotate forward, the wheels also rotate forward. So when I try to change the direction of the vehicle while actually going in a turn, maybe in a guard section or wherever you're trying to take a turn, there will be gyrocouple acting. So that gyrocouple can be, now the direction can be like analyzed like this. Okay, so the same thing can be used for a ship, the same thing can be used for a aeroplane. Okay, so you're given for an aeroplane, suppose it is an aeroplane. Okay, I'm the pilot. There's a, so what is this then? Is it a wheel? It is actually a propeller. Okay, it is actually rotating like this, Now I am the pilot. I want to go to Chennai. Okay, which side is Chennai? Left side or right side? Right now in this direction. Okay, which side is Silk Board, Osur Road? Right. For me, say Silk Board is this side or this side? This side. So I am trying to go this way. If I try to go this way, then you will see that when I want to turn like this, when I want to turn like this to left, you see that when I want to turn left, then this noise, then the aeroplane is trying to dive forward. If I want to go to Mumbai or if I want to go to Mangalore, then if I turn like this, okay, if I turn like this, the wheel is getting lifted. So that means the aeroplane, it is not just the wheel, it is the propeller of the aeroplane. So when I want to go to Mangalore, the wheel is getting lifted when I want to turn to left. But when I want to go to Chennai, it is going downwards. It's not Chennai or it's not Bangalore. Okay, it's just giving the direction. Use this same vector diagrams. You'll find out that the directions which the way the couple is acting is actually has some meaning. Okay, you please follow these rules, and this is how you try to find out the couple acting on the wheels, and finally the answer will be in Newton meters. Okay, so you know what is actually couple. If you place 1 kg here, if I place 1 kg here, so can you hold 1 kg in your hand like this? You can't hold, you can hold. Okay, if you hold 5 kg, so there's a moment created. So 5 kg, suppose if your hand is 1 meter, now the moment created on your hand is the same as this couple. It's trying to flip it, it's actually trying to flip it like this. Okay, so it is almost like 5 kg of load at one end of your arm, and the amount of the moment which is being created on the arm, the same moment is being created on this shaft which is holding the wheel. So this is how you calculate the gyrocouple, which is the product of I omega p. I think for all the rotating masses which are actually trying to take a turn, that means that it's trying to change the axis, you need to know at what speed they are rotating, and also at what speed they are trying to take a turn. That is called as, taking a turn is called as omega p, precision. Okay, so if you know, suppose we can calculate these two, then if you know I,